we put together something that is now called the Geosystems Engineering and Hydrology degree program. Boy, we are really big on long names, okay? So I'm here to tell you about this, and you can actually read it probably just as well as I can, and I can tell you now what 30 years of experience with this program has been as we think in terms of geology and engineering. One of our biggest problems was the last bullet there, is that at our university, geological sciences is separate from engineering, and it had to be jointly administered. And so that meant that a student came to the university as a GEH student. He had to be admitted to geology for 2 years. We couldn't count him for 2 years. And then they would be transferred over to engineering. And the last 2 years, they were counted for us. So, okay, we had it. We had to do a lot of negotiation. In a quick summary, we stripped out what we used to call the pig iron courses. We stripped out drilling. We stripped out production. We stripped out several, and we added to 20 some odd hours that were physical geology, sedimentary rocks, things like that, and some electives. And we retained a lot of the petroleum courses, and I think perhaps that may have been not a good idea, but it was a separate degree. And here's the kind of the summary, is that the number of courses taken in petroleum engineering was reduced by about half. 29 credits in geological engineering, much more than what petroleum engineering takes. 6 elective credits. And the upshot of it, after you waded through the whole thing, was there's a lot of similarity. There's 132 credit hours. Our degree program was 128. And so, as I said, we've had like 30 years or so experience with this program. But I remember the night up at the Tulsa meeting in about 1978, or maybe it's 1980, when I was sitting in a hospitality room with a guy named Herb Carroll, who was in charge of the Nettle office. And he said to me, what's the next best thing? What's the next biggest thing in petroleum engineering? Now, they had just gone through a period of time where they funded a number of field tests on enhanced oil recovery, and most of them performed poorly. And I said, Herb, I said, I don't think we have a clue as to what we're putting these chemicals into, or CO2 or whatever. And I think that's still true to a large extent. And so I talked and I talked and I talked. And 6 months later, an RFP comes out with exactly the words I said. So those of you that are thinking if you can influence policy, and Charles had some good ideas there, this is a way to do it. Kind of talk to folks ahead of time, and probably it won't work, but it just may. So I embarked upon a number of projects over the next 10 years that fell into reservoir characterization. I have a bunch of slides to support this, but the time is going away, so let me just summarize it here. The first thing, I got a grant. Second thing was, we'll give you the money if you find a geologist to work with. And I said, a what? Why would I need a geologist? Honestly, why would I need a geologist? And so I found a guy named Al Scott over there, and he introduced me to Gary Kasurik, and he introduced me to several people that worked at the Bureau. And I have off and on over the years worked with geologists, and so I have a pretty good feel for them as well as the subject. So here we go. First thing is, geology is endlessly complicated. If you think you're going to learn geology in one semester, you're wrong. Okay? Endlessly complicated. I sat in on discussions with Randy Merritt and Steve Laubach in which they seriously debated as to whether geology was really a field of study, since everybody was their own major. It's true. It's true. It is much broader than petroleum application. Always remember, there's a lot more of them than there are of you. A lot more. How many petroleum schools in the United States? 20? On? Okay. Okay, that makes it 21. Thank you. Okay. But every university in the United States has a geology department. And most of those geologists can barely spell petroleum. That's true at the University of Texas. We do not have a single person that I would call a petroleum geologist in our geology department. So don't think just because somebody's a geologist, they're going to know what you're talking about. So endlessly complicated. And as David told me, David DiCarlo, my colleague, told me as we were driving up here, he says, we're really not interested in geology. We're interested in flow through porous media, aren't we? Okay. So everything's heterogeneous. Yeah. Don't be surprised. Those of you that are working in the unconventional area, do not report to me breathlessly that you found the reservoir to be heterogeneous. Everything is heterogeneous, okay? At all scales. And I've found out over the years that most people tend to grab a certain scale and they stick with it. If you're a core flooding guy, you will start as a core flooding guy and you will retire as a core flooding guy. Okay, if you look through microscopes, you will retire looking through microscopes. If you look at well test data, you will retire looking. It's the truth. Nobody crosses scales. Or do they? I had some ideas about this scale business, but you're going to have to pay me more to talk about that. And one of the complexity is in geology. You know, most of them don't know what permeability is. They have a dim idea of porosity. Okay, so there are many, many surrogate properties. There's texture, there's grain diameter, there's color, there's all sorts of things. And in many cases, you have to infer the things that you want to know from the surrogate properties that they characterize. Generalization in geology is possible only at the highest level. Do you know that people can get master's degrees from a different piece of rock? They'll study an outcrop over here. They'll go across the valley. There's a master's degree there. They'll cross the valley. There's another outcrop there, and there's another master's degree. So it's like everything is unique. Everything is unique. So any generalization that's there is possible only at the highest level. Depositional environments, basin scale, things like that. The good news for us is since we're interested in flow, only some of these properties are needed. In fact, most of the properties are not needed. Autocorrelation, which is a subject that came to us through the field of geostatistics, and that's a story in and of itself, isn't it? Right there. Autocorrelation is huge because it's very, very common to measure something right here and have some assurance that some distance away it's the same thing or about the same thing. It's not always that way, but it is that way statistically speaking, and that's really the reason why we have as much success as we have had, is that things tend to be autocorrelated. And I think the last one here is, I don't know, I started off studying layered models. I thought things that was way too simple, and now I'm going back to layered models. So I think layered models of reservoir flow through reservoirs is a pretty good way to do it. It's a compromise between a homogeneous reservoir and basically a geostatistical description, which are getting just about as complicated as the reservoir is, right? So that's my geology emphasis.